problem 3. First thing I have to do if I'm trying to simplify this is I got to simplify that radical. So when I mess with that, we'll mess with it over here. Square root of negative 27. Well, I know that's basically a negative 1 since there's a negative inside it. There's going to be a 3 times a 3 times a 3. If I do a factor tree for it, I can see I have 9 times 3. That's prime. Can't go any further. That breaks down to that. So I have 3 3's and a negative 1. That negative 1, when it comes out, the square root of negative 1 is always represented by the letter I, the imaginary number. Also, we have a pair of 3's, so it's going to come out. So on the outside, we're going to have 3i square root with a 3 left behind. So this guy right here is going to be a negative 15 plus or minus the square root of negative 27 simplifies to 3i root 3 all over 12. Now all I have to do is I look and I say, okay, remember this and this, never going to be messing with the denominator and what's inside that radical there. It's going to be this, this, and this. These are the guys that I'm going to concentrate on. What number can 12, 3, and negative 15 or 15 be divided by? The answer is 3. So I'm going to divide each of these by 3 to go ahead and simplify this fraction. 3 divided by 3 makes him 1. 12 divided by 3 makes him 4. And negative 15 divided by 3 makes it negative 5. So the final answer here, when we clean it up, the top, I have negative 5 plus or minus 1i, which we just write as I, because 1 times anything is just the thing, root 3. So this is I root 3. And then on the bottom, we have a 4. This simplifies to that. Again, break down the radical. If you see a negative, you know basically you're going to have an I out here. That's how we're going to get rid of it, because really it's a negative 1 inside, and the square root of negative 1 by definition is the imaginary number, which we, again, label just as I.